the things that do not have bases that are parallel to each other. So let's talk about pyramids. Or you know what, let's do cones, because I think a cone is a little bit easier to see. Let's say that I have a cone. I am going to, if you can imagine, I'm going to take my cone and I'm going to put it inside, all right? This is my cone. But if you can imagine the cone inside a cylinder, okay? Now, if I was trying to find the area of the cylinder, I would take the base and I would multiply it by the height, okay? My base is still a circle, right? Here's my base. My base is a circle, okay? So my base is still pi times the radius squared, right? So let's say we'll still leave our radius as 10 because that worked out so well last time. So my base is still going to be 314 units squared. Now, instead of a cylinder, I have a cone. It's like a sugar cone that you would put your ice cream into, sort of flipped upside down. When I was going to do this in class, I had used a toilet paper roll, the paper from the inside, and I had made one of them into a cone, and I had one that was a regular toilet paper roll, and I was going to demonstrate this to you, but we're just going to have to visualize it with the drawing on the board. Here's what I want you to notice, if you can, is that this cone, the volume inside this cone, all right, is 1/3 of the volume of the cylinder. If you can imagine that this whole side, if you took this and sort of wrapped it around itself, and you took this one and wrapped it around itself, it's sort of like, right? You've got this, we're counting, we're not going to count that, and we're not going to count that, okay? So basically, when we talk about a cone, or something that has a pointy top on it, it is 1/3 the volume of the prism, or the cylinder that it sits inside of. So when I talk about the volume of a cone, okay, the volume, instead of being equal to just the base times the height, we're going to add a 1/3 in front when we talk about a cone. Because a cone, we still figure out the area of the base, multiply it by the height, but if we have something that comes to a little pointy top on it, we have to divide it by 3 because it's 1/3. And when I had, when I was going to prep for it, what I had done is I had popcorn, and I filled the cone with popcorn, and we could watch and see that it took 3 cones to fill the same radius toilet paper roll. But you're going to have to trust me on it now because we didn't do class. Okay, so when we talk about a cone, we want 1/3 the big base times the height, and remember that the base is a circle. Okay? Let's look real quickly. A pyramid is the same exact thing. When we talk about a pyramid, you're going to do the same thing. So let me see if I can draw, here we go. Okay, we're going to try to draw, I'm not very good at drawing pyramids, but I will give it my best shot. Here, we'll make if we make a short one, I think I can actually do a better job of it. Oh, that's weird. Look at that. That did not work, because I don't think you'd ever have a pyramid that... Anyway, all right, good enough. You can get the gist of it. If I have a pyramid, it's the exact same thing. So the volume of a pyramid is equal to 1/3 the big base times the height. Now here, for my pyramid, I have this is a square pyramid. You can have a rectangular pyramid. You can have a triangular pyramid, because just like prisms, pyramids are labeled by their base. So we look at the base and we use that to name it. So what I have here, if I say that this is 6 and this is 6, right? Then this is this is a square pyramid. And I would say my base, right, is equal to 36 units squared. Now, when I talk about height of pyramids or cones, what you have to remember is I'm talking about an altitude, because I take that point and I drop straight down to the floor, and I want something that's perpendicular to the floor. So let's say that this is, you know, whatever, we'll make it 10 because it makes it easy. This is called the altitude. If I were to take and measure down this way, right, that is called a slant height. And a slant height, I'm sorry to say, is completely irrelevant when we're trying to calculate volume. It's important if I'm figuring out how much wrapping paper it would take to cover it, but it is not important when I'm figuring out volume. Volume is the base times the height, which now is called the altitude, right? The base times the altitude, and I have to divide it by 3. So here I would say I'm going to go, the volume is equal to, right, 6 times 6, which is my base, 36 units squared, times my altitude, which is 10 units, and I would divide that by 3, and I would probably divide it by 3 beforehand because it makes it a whole lot easier. So I'm going to make that a 1 and a 12, and I'm going to get that the volume of this square pyramid is 120 units cubed. Okay? All right, the only other one we have to do for volume, I'm getting wore out because I don't normally have to talk this long uninterrupted. You guys usually chit-chat.
You have 3 minutes left.
Okay, so here we go. I'm going to do one more thing. Hannah says I'm running out of time on this particular video.
Really out of time, better go fast.
Is a sphere, and a sphere, you're just going to take my word for it. I don't have time. I was going to put it in a cylinder and talk all through it, but a sphere, S-P-H-E-R-E, is equal to 4/3 the circle in the middle, okay? 4/3, okay, the area of the middle. 4/3 pi times the radius squared is the volume of a sphere, okay? So you're just going to have to take my word for it. If this is 30, right, then the volume of my sphere is going to be 4/3, right, times pi, which is 3.14, times, now you could also use 22/7, depending on what you're doing. So pi is also equal to 22/7. And then I'm going to times it by 30, and I'm going to times it by 30. So I'm doing this specifically because I was trying to make it cancel out. So this makes 10 up here, and a 1 down here. Oh, and what I end up with is, let's see, I would end up with 3,140, no, times 12. 8, 2, 6, 3, 1, 4. So I would end up with 3,768 cubic units in the volume of this sphere. Okay, I'm going to stop now because I'm running out of time, and hopefully I will return and do a second video.